Hello, I'm Richard Canese Jr. So for this video, I'm about to discuss to you the scientific notation. And before we go to our proper discussion, let's have first our objective. So in this lesson, challenge yourself to attain the learning outcomes. First is to discuss the scientific notation. Second is write numbers from standard form to scientific notation and vice versa. So what is scientific notation? Scientific notation is a way of expressing numbers that are too large or too small to be conveniently written in decimal form, since to do so would require writing out an unusually long string of digits. In other words, scientific notation is a form of presenting very large number or very small numbers in a simpler form. As we know, all numbers can be extended till infinity, but we cannot write such huge number in a piece of paper. Also, the numbers which are present at the million place after the decimal needed to be presented in a simpler form. Thus, it is difficult to represent a few numbers in their expanded form. Hence, we will use this scientific notation. As discussed, scientific notation help us to represent the numbers which are very huge or very tiny in a form of multiplication of single-digit numbers and then raised to the power of the respective exponent. The exponent is positive if the number is very large and it is negative if the number is very small. So we have here the example of the scientific notation. So we have here 45 million, 4,500,000 is equal to 4.5 times 10 raised to 6. So the coefficient there is 4.5, the base is 10, and the exponent is 6. And also we have here the example of the decimal form. So we have here 0.00453 is equal to 4.53 times 10 raised to 3. The coefficient there is 4.53, the base is 10, and the exponent is 3. The general representation of scientific notation is A times 10 raised to B. 1 is less than or equal to A less than 10. So we have here the scientific notation rules. To determine the power or exponent of 10, we must follow the rule listed below. First, the base should be always 10. Second, the exponent must be a non-zero integer. That means it can be either positive or negative. The third, the absolute value if the coefficient is greater than or equal to 1, but it should be less than 10. Fourth, the coefficient can be positive or negative numbers including whole and decimal numbers. 5. The mantissa carries the rest of the significant digit of the number. So, we have here the following common numbers written in scientific notation. So we have here 1,000,000, 1,000, 1,000, 1/10, 1/10, and we have here 100, 1,000, 1,000,000, 1,000,000,000, and 1,000,000,000,000. As you observe from this table, we can see that the number that is written to decimal form or the large number, we expect that the exponent is positive. So if the base is, if the base is whole number, we expect the exponent is positive. Or if the base or the number is large number, the exponent is positive. So if it is written in a decimal form, we expect that the exponent is negative. So we have here how to write numbers in scientific notation. There are steps in writing decimal numbers into scientific notation. First is to identify the initial location of the original decimal point. Step 2. Identify the final location or destination of the original decimal point. The final location of the original decimal point must be directly to the right of the first non-zero number. The third step is move the original decimal point to its final location. You will get a number here called E. Its value must be greater than or equal to 1, but less than 10. When the decimal is moved towards the left, the count for the exponent of base 10 is positive. When the decimal is moved towards the right, the count for the exponent of base 10 should be negative. And the last step, write C multiplied by some power of base 10. It should look something like this. C times 10 raised to n. So we have here the example of how to write decimal number into scientific notation. So we have here the example 1. We write the given decimal number 3800 in scientific notation. So starting with the first step, we start by identifying where the original location of the decimal point and its new location. So we have here the new location, decimal point, and the original decimal point is here, and the new location decimal point is here. So this is where our original decimal point and our new location decimal point. Now we move to the decimal point from the starting point or the original decimal point to its final destination, while counting the number of decimal places. So we have here count the number of decimal places from the original decimal point to the new location decimal point. So we have here 3 places to the left. Remember the rule above, if the decimal is moved toward the left, the count for the exponent of base 10 is positive. So our exponent must be positive. Since there are 3 places to the left, that makes our value of C as 3.8, and the power of 10 is raised to 3. Putting them together in the required format, our final answer would be 3.8 times 10 raised to 3. And always remember to make sure that the C value always has the decimal point right after the first digit, which is the case here. We have here the example of how to write decimal numbers into scientific notation. This is about the negative power. So example, we write the given decimal number of 0.0005 in scientific notation. So it is obvious that the original point is to the left of the non-zero digit. We will move the decimal point going to the right. So this is our new location of decimal point, and this is our original decimal point. Remember, when the decimal point moves towards the right, the count for the exponent of base 10 should be negative. So we have here 0.005. We count the number of decimal places from right to the left. So we have here 4 decimal places to the right. Moving the decimal point to the right should yield a negative exponent for the base 10. So counting the number of decimal places, we have 4. So the final value of coefficient is C is equal to 5. And the power of the base 10 raised to is negative 4 since it is positive. So our final scientific notation answer should be 5 times 10 raised to negative 4. So that's our final answer. And we have here letter C, convert, how to convert scientific notation to standard form. Example 1, we convert 3.400 3.456 times 10 raised to 4 in standard notation. So solution 3.456 times 10 raised to 4. 10 raised to 4 is equivalent to 10,000. So we multiply 3.456 times 10,000. It will give us 34,560. Or since you're multiplying a power of 10 positive, just move the decimal 4 units to the right. So we have here 345,603.456 times 10 raised to 3 is equal to 3.460. And also we have here the example 2, convert 3.456 times 10 raised to negative 4 in standard notation. So solution 3.456 times 10 raised to 4 is equal to, the equivalent of 10 raised to negative 4 is 0.0001. So if we multiply 3.456 times 0.0001, it will give us 0.0003456. Since you're multiplying of 10 negative, just move the decimal 4 units to the left. So convert scientific notation to standard form. 3.456 times 10 raised to negative 4 is equal to 3.456 times 0.001 is equal to 0.0003456. And we have here the example 3. A distance if Saturn to the Sun is about 8.84 times 10 raised to 8 miles. So solution 8.84 times 10 raised to 8. 10 raised to 8 is equivalent of the equivalent of 10 raised to 8 is 100 million. So if we multiply 8.84 times 100 million, it will give us 8.84 million. So it is equal to 884 million miles. I think that's end with my discussion. I hope you learned something from this video. Thank you for your time and goodbye.